So let's have a basic example, very basic example of a particle moving according to a certain path. Suppose that path is f of t equals to t to the second minus 3t plus 2. So we have a particle that is, it's moving according to this parabola. And let's say that for the discussion of, since we usually don't deal with negative time, say that t is greater than or equal to 0. And let's say that the units are feet and seconds. So feet and seconds. And I say that the first part A, the question is asking us, what is the velocity at time t? So velocity at time t. Well, what is velocity? We said that velocity is the derivative of the position f of t. So in this case, derivative of f of t is f prime of t. That gives me 2t minus 3. And let's say that we want to know what is the velocity at 4 seconds. So velocity after 4 seconds. So 4 seconds has gone by, exactly 4 seconds. So what is that, the velocity at that precise moment? Well, that's not hard to find. F prime of 4 equals to 2 times 4 minus 3. 2 times 4 is 8, minus 3 gives me 5 feet per second. I'm going to go ahead and page up. I'm using my iPad. Let's say part C is asking us that when is the particle at rest? So when is the particle at rest? Well, the particle is at rest when velocity equals 0. So if I need, f prime of t, I have to set that equal to 0. But what was f prime of t? F prime of t was 2t minus 3. So 2t minus 3 equals to 0. And this follows that t equals to 3/2 or 1.5. So precisely at that moment, when t is 3/2 or 1.5, the particle is at rest. And let's say part D is asking us, when is the particle moving? When is the particle moving in positive direction and when is it moving in negative direction? So I'm going to put also negative direction. Well, we know if the value of the velocity is negative, it's going in negative direction. If it's positive, it's going to it's going to the positive direction. So let's say starting from 0, because we decided to start from 0, and keep going all the way. And let's say that is going to be the v of t, which is the same as f prime of t. And we know that 3/2 is the particle at rest. Notice any value I plug into the velocity into 2t minus 3, I get negatives here. So the particle is going in negative direction, and then it's 0 at 3/2, and it's going in positive direction, any values after 3/2. Like for example, if I plug in, say, 2, 2 times 2 is 4. 4 minus 3 is 1, and it's positive. Let's say if I plug in 1, which is a value between 0 and 3/2. So if I plug in 1, I get 2 times 1, which is 2, minus 3 is negative. So I get a negative value anywhere between 0 and 3/2. Even 0 itself, if I plug in 0, I get a negative value, I get a negative 1. Okay. So how do we say that? How do we answer this question? We say for, let me go to another page. We can say positive direction. For the positive direction, we have t has to be greater than 3/2. And negative direction, t has to be between 0 and 3/2. 0 included, and 3/2. 3/2 is not included because the particle is at rest. Okay. Next part, the question can ask something like, what is the total distance traveled during the first 4 seconds? So part E, let's say it's asking for total distance traveled during first 4 seconds. Okay. So we know that the particle was going to the left first, and negative directions, and then to the positive. So it turned around. So the path was something starting from here was like, like something like this. So now I have to do the distances in 2 times. Once from 0 to 3/2, take the absolute value of that, and then add it from 3/2 to 4. So here I can say that absolute value of, let me erase this so I have room. Absolute value of f of 3/2 minus f of 0 plus absolute value of f of 4 minus f of 3/2. That part shouldn't give you any trouble. It's just like basic algebra. So adding the first part, absolute value of 3/2 minus absolute value of 0, this part happens to be 9/4. And this part happens to be 25/4. So the total distance is going to be 9/4 plus 25/4. That gives me 34/4, which is the same as saying 17/2 feet is the total distance traveled. Most textbooks after that ask for some sort of diagram to just make sense that, hey, you know, what was the path? So a diagram is going to be, let's say that if this is 0 for our t and it keeps going at time 0, it went to the left for a while and then went to the positive direction. So first it went to the negative directions, turned around and went to the positive directions. Let's say that now we are interested to find what is the acceleration when at t, let's say, equals to 4. Okay. So what is acceleration? Acceleration is the same as the derivative of velocity, which is the same as saying the second derivative of f, and that equals, taking the second derivative, I get only 2. 2 what? 2 feet per second or per second squared, the unit for acceleration. The next part I. And so as you can see, the acceleration in this case is constant. No matter what time you choose, the acceleration will be 2. Okay, let's say part I, usually textbooks ask for, you know, graph position, which is f of t, velocity, which is f prime of t, and acceleration. Okay, which is f double prime of t. So, you know, I'm going to go ahead and write here, use calculator. It's going to take me forever in this iPad if I try to graph it for you. Now let's say that part J, the question is asking us, when is the particle speeding up? When is it slowing down? So when is the particle speeding up? And let's say slowing down. Okay. Well, the particle is, you know, speeding up when both velocity and acceleration have the same sign. They're both positive or both negative. It is slowing down if the signs are opposing each other. So the easiest way is to just write down velocity and write down acceleration. Remember that for the, you know, velocity, we said starting from 0, and here was 3/2, and all the signs were negative here, all the signs were positive in here. And for the acceleration, we said that the acceleration was 2 feet per second, so everything is positive. No matter, starting from 0, no matter what t is, the velocity is positive. The velocity is positive. So notice that the velocity, let me put v here and put a here, they do have the same sign, okay, anywhere from 0 to 3/2. So I'm going to say that it's speeding up, from 3½ not included because the particle is at rest, 3½ all the way to infinity. Or you could say t greater than 3½ It doesn't matter to me. Slowing down. Okay, slowing down would be from 0. 0 in this case is included because the velocity at time 0 is negative, and at the time 0 the velocity is positive. So this case is going to be t has to be greater than or equal to 0, but it has to be smaller than 3½ And finally, one baby step that some textbooks, some authors like to ask is that the total displacement, not the distance, total displacement. So part K, find total displacement. What is total displacement? So, or change, in math, we use S for displacement equals to, so let's say total displacement for first 4 seconds. So now I have total displacement equals to the position, the last position, minus the first position, which is time 0. Okay. Let's see. S of 4, plug in 4, and you should get a 6. Plug in 0, f of 0 gives you 2. So you have 6 minus 2 equals to 4. For what? 4 feet. Okay, and that's the end of this example. I really hope you find this helpful. I'll be making more videos. Let me know if you have any questions, please.